Beneath centuries of dust and memory, beneath wars won and kingdoms lost, a quiet record has survived, not carved into stone, not preserved in parchment, but written into flesh itself. Across deserts, port cities, mountain passes, and modern megacities, a question still echoes through time. Who are the Jewish people? Really? Strip away the rituals, the languages, the borders, and the myths, and one mystery remains. What does the body remember when history forgets? From the sun-scorched paths of the ancient Near East to the glowing streets of New York, Paris, and Tel Aviv, science has begun to listen to a voice older than empires. DNA, the silent archivist, has started telling a story more complex than exile, deeper than belief, and older than recorded history itself. Tonight, we travel backward through millennia, not guided by prophets or chronicles, but by chromosomes and genetic code. This is the hidden biological journey of the Jewish people, one of humanity's oldest and most resilient lineages. Before we begin, welcome to the channel where science meets forgotten history. Here, we decode DNA, resurrect lost ancestries, and bring ancient genomes to life through cinematic storytelling. If exploring humanity's deepest roots excites you, make sure to subscribe, like the video, and comment below. Your questions shape the journeys we take next. The Jewish people form one of the longest surviving communities in human history. Across more than 3,000 years, they have endured conquest, exile, conversion, persecution, and rebirth. Today, over 15 million Jews live across the globe, speaking dozens of languages, practicing diverse traditions, and living in vastly different cultures. Yet for centuries, one question challenged scholars and skeptics alike. Were Jews connected primarily through shared faith and culture, or did an older biological bond unite them beneath it all? For generations, this debate lived in theology and philosophy. But now, modern genetics has entered the conversation, offering answers written not in ink, but in nucleotides. Researchers have examined the DNA of Ashkenazi Jews from Eastern Europe, Sephardic Jews from Spain and North Africa, Mizrahi Jews from the Middle East, and even the Beta Israel community of Ethiopia. What they discovered stunned historians and scientists alike. Beneath visible differences lies a shared genetic foundation, older than modern nations, older than religions as we know them. To understand it, we must return to the dawn of this lineage, long before temples and scriptures, to a land where civilizations were just beginning to rise. Genetic and archaeological evidence points clearly toward the ancient Levant. Around 3,000 to 4,000 years ago, during the Bronze Age, ancestral Jewish populations emerged among Semitic peoples living between the Mediterranean coast and Mesopotamia. City-states like Canaan, Ugarit, and Ebla flourished, while nomadic tribes moved between fertile valleys and desert corridors. DNA confirms that many Jewish paternal lineages trace directly back to this region. Specific Y chromosome markers, especially haplogroups J1 and J2, appear frequently among Jewish men today. These genetic signatures are also found among other Middle Eastern populations, linking Jews to ancient Semitic ancestors who spoke languages related to early Hebrew. This shared paternal heritage suggests a common origin rooted firmly in the Near East. But maternal ancestry tells a different, more layered story. Mitochondrial DNA, passed from mother to child, reveals that many Jewish communities incorporated women from surrounding populations over centuries of migration and exile. European, North African, and regional maternal lineages blended into Jewish communities as they spread across the ancient world. Jewish DNA is not a frozen relic. It is a living time capsule, anchored by a Near Eastern core, yet shaped by the lands of exile and refuge. History etched its marks deeply. In 586 BCE, the Babylonian destruction of Jerusalem scattered Judean populations eastward. Some returned, others remained, planting Jewish roots along the rivers of Mesopotamia. Centuries later, Roman legions shattered Jerusalem once again, dispersing Jews across the Mediterranean world. This dispersion created remarkable genetic diversity, yet did not erase the original thread. Jewish genomes today reveal a Levantine backbone interwoven with Greek, Roman, Berber, Iberian, and Slavic elements. Despite oceans crossed and languages adopted, the ancient signal persisted, echoing quietly across generations. During the medieval era, Jewish communities flourished along major trade routes. In North Africa and the Islamic world, Jews lived among Berber dynasties and caliphates. In Iberia, Sephardic Jews thrived intellectually and culturally, until the Inquisition of 1492 forced exile and conversion. Genetic studies show that Sephardic Jews retain strong Near Eastern ancestry, alongside Iberian and North African genetic layers, reflecting centuries of coexistence. Ashkenazi Jews, who later emerged in the Rhineland and Eastern Europe, carry a similar Levantine foundation. Yet studies reveal that roughly 30 to 50% of their maternal ancestry traces back to European women, likely converts or local spouses who joined Jewish communities during medieval expansion. This reveals a profound truth. Jewish continuity depended not only on bloodlines, but also on cultural adoption and shared identity. History left scars on the genome. Pogroms, ghettos, and the Holocaust created severe population bottlenecks, intensifying certain genetic traits among Ashkenazi Jews. This helps explain the higher prevalence of hereditary conditions such as Tay-Sachs disease and specific BRCA mutations. Meanwhile, Mizrahi Jews, who remained closer to the ancient homeland, show remarkable genetic continuity with ancient Levantine populations. Ethiopian Jews, known as Beta Israel, add yet another layer. Their DNA reflects strong East African ancestry alongside traces of ancient Semitic origins. Scholars suggest a blend of early Jewish influence, trade connections, and local conversions, demonstrating once more that Jewish identity expanded through both lineage and belief. Taken together, these genetic branches form a vast family tree, deep-rooted yet wide-reaching. Despite centuries of separation, studies reveal that most Jewish groups still share 40 to 60% of their ancestry from the ancient Levant. That means a rabbi in Brooklyn and a merchant in Baghdad may be genetically closer to each other than to their non-Jewish neighbors. Still, DNA alone does not define identity. Genes do not light Sabbath candles or preserve sacred songs in secret. Culture, memory, and tradition breathe life into heritage. Genetics simply confirms what history has long suggested. The Jewish people are bound by an ancient biological thread, strengthened, not erased, by exile and adaptation. Today, millions turn to genetic testing to rediscover lost family branches and long-forgotten connections. For some, DNA uncovers hidden Jewish roots. For others, it reinforces what faith and family already knew. In the end, the Jewish genome teaches us that peoplehood is not static. It evolves, shaped by survival, belief, and the quiet persistence of memory. So what does this genetic journey ultimately reveal? It shows that beneath the many faces of the Jewish diaspora lies an ancient, resilient core, encoded in both body and spirit. From the sands of Canaan to the streets of the modern world, Jewish DNA carries the memory of prophets and poets, exiles and visionaries, sorrow and survival. Which part of this hidden journey surprised you most? Did science change how you see heritage and identity? Share your thoughts in the comments. Your voice deepens this conversation. And if this story moved you, like, share, and subscribe for more journeys into the genetic histories that shape our world. Because the past is never truly gone. It lives within us, written in our cells, echoed in tradition, and waiting to be remembered.